So without further ado, I'm going to jump right in. I'm going to hand the meeting off to our software education coordinators and professional development chairs, and I hope you guys enjoy the meeting.
All right, hello guys. Welcome to today's meeting. I'm David. I'm a second year computer science major at UCLA. Nice meeting all of you guys. And yeah, so we're going to go over the anatomy of internships today, and specifically, what do internships applications look like in right now in 2025, and how do you stand out in an application? So as you can see right here, we have screenshots from a live application. This is Waymo. So any standard job application will look like this, no matter what roles you are interested in, like whether it is software engineering, product management, whatever. You will all have to fill out the standard form. These should be pretty quick, as you can see. Fill out your name, email, like contact information, upload your resume. Sometimes they ask for cover letter, which usually should be optional, but it's encouraged that you have a strong cover letter that demonstrates your interest. Personal website, LinkedIn profile, and a few other miscellaneous questions. Some applications like NVIDIA Ignite can have like essays, so that's also another thing as well. Think about this kind of like your college application, but a lot more brief with a lot more emphasis on your resume. Yeah, and this is also the other parts like they ask you what school you go to, what year are you. If you guys don't know already, your graduation year is pretty important, especially for software engineering roles. A lot of um a lot of companies only hire like juniors or people who are about to graduate. Yeah. And then at the end, you just submit your application and then you're good to go.
Hi everyone, I'm Lily and I'll be going over the application process. So with our application process, not ours, I'm sorry, with the like general software engineering application process, there's usually three steps that you will go through. So after you filled out the application form, um, they might contact you with first an online assessment. After that, you can move on to a recruiter screen. And then finally, there's a few rounds of interviews. So online assessments, usually they're called OAs, and these are usually the first stage that they send you in the interview process. And while the order may vary, maybe sometimes they'll have a recruiter screening first before an online assessment. Like generally, you have either one or the other. And for online assessments, these will be usually in the style of leak code, and which will test your data structures and algorithm solving skills. And online assessments, there's a few types. Typically, if they're from a very big company that's very well known, such as like FANG companies or TikTok companies like that, they'll give you like a timed exam that usually is between an hour or 2 hours. And they will have a few questions. The number will range between like two to four. And these questions are the LeetCode style. You can do them at home because you just do them on your laptop. And between companies, they will have like different difficulty. And just in general, this is just meant to be a way to filter out applicants. So people who possess like strong problem solving skills, data structures, and algorithms will be able to move on to the next round. And the resources. Oh, also the second type of online assessments would be longer in length. Companies like SpaceX might do this. They'll send you a coding challenge, which they'll give you maybe like between like let's say 8 hours to a day to do. So you have more time flexibility, like you to work on them. But those challenges will be typically like harder and will require like more thought to do them. And resources for preparing for OAs include LeetCode. LeetCode is a platform where you can practice all kinds of DSA, data structures and algorithm questions. And that's just the resource that everyone uses is very, very comprehensive. And now you might be wondering, like, because there's like 3,000 questions on LeetCode, like, how do you figure out which questions to do? And one very good resource is the Neat Code Roadmap. So if you go on to Google and you just search up Neat Code Roadmap, the first link will be on there. And that just provides a very good roadmap of what skills you can learn, as well as what types of problems you should do. So it will start with like arrays, and then it'll move on to like other topics like hash maps, etc. And our club will focus more on, we will be teaching you how to do online assessment style questions, and we will focus on understanding the algorithms rather than pattern detection or memorization, because it is very important to know what is like how to solve the problem, or how to solve any type of problem that is similar to like a topic. And then after that, we have the recruiter screening. So this is just very simple. It's like a casual phone talk. Um, the recruiter will be asking you questions about like just very behavioral oriented questions. So it would be focusing on like sections of your resume where you have your like where you talk about more leadership focused skills, or what like extracurricular experiences you have. And then if you get past the online assessment and the recruiter screening, the final stage is interview screening. And this consists of multiple rounds of either technical rounds, behavioral rounds, or a mix of both. So with the technical round, it's very similar to an OA, but this time you have to implement coding solutions to coding questions live to an interviewer. So this focuses a lot on your skills to how to explain how to solve a problem, not just being able to solve a problem, but also your communication skills. And then there's also behavioral rounds, which is kind of similar to a recruiter screening, except you might be asked more questions that test your soft skills, like how do you work on a team, what challenges you've experienced.
So I just want to jump back in. You guys had a lot of information thrown at you. There's really four pillars to the application process, four things you can control. And I've even ranked them for you to make it easy to learn. The number one most important thing are your skills. How good are you at passing these leak code questions? How good are your projects? What is the quality of the projects you're building? The second thing that is most important is your network. Having the right referral, having the right connection is incredibly important. Oftentimes, these networks are inherited by your surroundings. Bruin Software Engineering is going to help change that. Not only do you have an access to a network of 150 students, we're going to teach you how to send your own cold DMs and actually get a response. I just recently found this out from a board member of Vest, which is another club at UCLA. Twitter has as high as a 25% response rate to cold DMs to the founders of startups. That's crazy, and that's something that not everyone knows. We'll be giving you tips like that. We'll be giving you templates so you can network efficiently, and we can actually kind of peel back that word and show you the mechanics behind it. After that, it's all about initiative and consistency. At the end of the day, it is up to you to go out there, apply to these companies, reach out to people, and do that consistently. Right? To give you guys some context, it's not that uncommon for people to apply to hundreds of internships every cycle. And I'm not saying you guys will have to do that. Our goal is to make that easier. It is something to keep in mind. Consistency and initiative are two things you really cannot avoid with this process. We're going to take a really quick break, and it's also a great time to ask any questions about the application process right now. And then we're going to jump directly into building some technical skills. So, does anyone have any questions about the application process? I think we're good. So, we're going to join back in about 1 or 2 minutes, and then we'll go straight into Git.
Okay, I think now's a good time to get started again. Hello, everyone. My name's Shiraz. I'm a second year at UCLA and one of the software coordinators for BSc. So, getting right into it, introduction to Git, understanding the basics. We're going to cover a lot of information here. So feel free to ask any questions in the chat and let's get going. Git is the most popular version control system today. It's an essential skill to learn for any aspiring software engineers, no matter what company you might want to work for. Version control allows you to track file or code changes in general over time. It helps you to collaborate better, makes debugging way easier, and also branching for easier experimentation and working with others. I'm going to cover branching a bit more in depth later in the presentation. GitHub.com is the most popular Git hosting service. Git hosting is the practice of moving your local repository or local code copy on your computer to a remote repository on GitHub.com. We have 4 dimensions of Git that are important to know. First is the working tree. This is going to be like your Visual Studio Code. We have a demo in the next slide where I'll explain that. So your Visual Studio Code and the files that you have on your computer and you save them. You have a Git command to move to the staging area, which is changes that you are ready to move over to the local repository. The local repository is going to be on your computer only, by the way. So you're going to use a Git command to move code from the staging area to the local repository. And finally, remote repository on github.com. There's another Git command to move there, and you can also go backwards. We're going to get into the depths, but just keep track of these 4 main dimensions: working tree, staging area, local repository, remote repository. Okay? Now, in this demo right here, you'll see my Visual Studio Code. I've done a command called git init. I'm making a repository, making a file called welcome, and I'm going to write a quick message in there. Now, I do git add. So this is taking the file welcome and moving it from the working tree to the staging area. Git commit right here, we're going from staging area to local repository. And there's some really cool other Git commands like git log. I'm able to see that commit that I just made. And I'm going to do git status, which is going to say that I'm on branch main. When our other software educator, Ishan, gets into branching, you'll understand what main means very soon. Now, you saw me in that video typing into something a black screen. That's called a terminal. Terminal helps you to interact with your code and your computer in general. We're going to go over some basic terminal commands right now. First one we have is pwd. If you're ever wondering in your code, where am I? What folder am I in? This is your command. Type it into your terminal and it'll give you the output. ls. This is going to tell you every file within the folder or directory that you are in. cd. If it's going to move you into any folder or directory you want to go into. rm is going to remove or delete a file from a directory. mkdir is going to create a new folder. cp with a source and destination is going to copy a file. mv is going to move a file, or you can use it to rename it as well. Some more commands would be cat. If you want to see the contents of any file, you can just do cat and the file name, and you'll get that. grep. Let's say you want to search a file for a specific pattern. You can use grep here. Instead of doing Control F or Command F and having to go through all the instances, it'll just give you them. grep-r very helpfully recursively searches for a pattern within a folder. So let's say you have 10 files and they're really large and you have them all in one folder and you want to search for one thing in all of them. This is your command. Nano is going to show you a file within the terminal. This is something that you maybe would have to use, but it can be helpful. Manual, the manual command is going to be a way for you to see what any command does. So you type in man space that command name, and you'll see a full list of options, sort of like a encyclopedia for commands, if you will. Now we're going to be covering some Git commands within the terminal. Some of them I typed in the video, and some of them you're about to see. So git init, this creates a new repository. This is what we did in the video. Git clone, if I made my repository on github.com, called BSE and I wanted to move it to my local on my computer or make a local copy of it, I would use git clone. Git status, see any changes that have been made. This is to see all of my changes, whether they're in the working tree or they're in the staging area. You can see them both. Git add with a period is going to help you move all files that are tracked into the staging area. Git add file, like I did with welcome.txt in the video, is moved welcome.txt from the working tree over to the staging area. And then you have git commit, which goes from the staging area to your local repository. And I titled my commit first commit in that video. And then you have some little bit longer commands, but they're not too bad to explain. So git remote add origin. Now, this is going to connect my local copy, that Git repository that I made in the video, to github.com. And then git push. So that, remember, I've talked about the working tree, the staging area, and the local repository a lot. Git push is going to go from the local repository to the remote repository. So git push-u origin main is going to do that final step to get you to that fourth dimension and make sure your code is accessible through by others. And then git pull origin main is if somebody else makes a change on main and pushes it, you can get that change on your end by doing a git pull. I'm going to pass it over to Ishan now.
All right, so over here we have a diagram that has a bunch of arrows. It has a bunch of arrows and it has these 4 dimensions that we talked about earlier: the working tree, staging area, local repository, and remote repository. So you can look at these arrows and see what command does what. But for me, an analogy I like using to help me kind of think of this setup intuitively is I'd like to think of the working tree as a busy factory. It's where things are happening, things are moving, and changes are being made. So the working tree is essentially where you're building a product, right? And I like to think of the staging tree as trucks that are ready to transport that product to a local warehouse. And in this case, we can think of the local repository as a local warehouse where you store your product that you've already finished. And the remote repository we can think of as an international warehouse that anyone can access the products in that warehouse. And you can move from the local repository to the remote repository. Or you can think of it in terms of the analogy as the local warehouse to the international warehouse by pushing. So now we'll talk about branching. Branching is a super important concept within Git. In my opinion, it's one of the best features of Git. What branching allows you to do is work in parallel with your teammates. So you can split up work and do it much faster. And it also helps keep your main branch clean. So what is the main branch? And what is like an example workflow you might use when you're using Git and branches? So the main branch is you can think of it as like a production ready line that you always want to keep stable. Your best form or your best copy of your code should be in the main branch. And if you want to change your code, like adding features, bug fixes, and multiple people want to do it at the same time, you can create branches. Branches, as I've said before, they allow you to work in parallel. And if you mess up in your branch or something goes terribly wrong in your branch, your main branch will still be intact and nothing will have gone wrong there. And after you've created those branches and you've tested your code that you've made in them for features, bug fixes, or etc., then you can merge them back into your main branch. What merging does is basically combines all your changes into the branch you want it to be combined into. And on the right over here, we have a diagram basically explaining that same thing. It goes from the master branch. We called it the main branch. That's what it's usually called. And you can see that one person creates a branch to do a bug fix. And while that bug fix is still going on in that branch, someone else creates a branch to make a new feature. So you can see they're happening at the same time. And then you can see the bug fix gets merged back into master, and the feature also gets merged back into the master or main branch. And then those features are implemented. So here are some branching commands. We talked about Git, like general Git commands earlier, but these ones are specific to branching. So Git branch, it just lists all the current branches you have in your local repository. Git branch followed by a branch name creates a new branch, but it does not switch into it. So say you were in the main branch and you did Git branch feature one. You would not be moved to feature one, you would stay in the main branch. Git switch followed by a branch name, it switches you to an existing branch. Git merge followed by a branch name merges all the changes from the branch that you specified into the current branch. So if you do git merge feature one, it'll merge all the changes from feature one into whatever branch you're in, which is probably main. Git rebase followed by a branch name, it's similar to merging. It just reapplies your current branch's commits onto the branch that you specified. And we'll talk about this on the next slide more. And then git branch followed by a hyphen and a D, it deletes a local branch that you specified, but it only works if you've already merged that branch into your main branch. So what's the difference between merging and rebasing? Because we mentioned both earlier. Merging is essentially combining one branch into another. This creates a merge commit, and you can see when and how that merge was done. And this is good for collaboration because your history gets saved and there's no rewriting it, but it can get very messy to see the exact changes that were made because after all, you're combining the branches. Rebasing, it reapplies your commits on top of another branch. So it overwrites whatever happened in main and updates the current position. This creates a clean linear history, so it's very easy to read the exact features or whatever's been changed. But it's like I said before, it overwrites whatever happened in main. So if you're collaborating, it can be very dangerous because you can completely remove someone else's work that they've done. And these are just the key differences. Merge keeps all your history, so it's completely safe. You can get merge commits, but those are much easier to fix than getting an entire portion of code wiped away. But I've said before, it's messy to see the exact history of all the changes made. Rebasing, it rewrites history, so it's clean, but it's risky because obviously you can delete code. So our general guideline is to use merge when you're collaborating with others, which is usually what you will be doing if you're using Git. So yeah, and use rebase only if you're working alone and you're sure no other changes have been made that could be overwritten. So honestly, you will probably be using merge most of the time. Another very important thing we wanted to talk about is a file named .gitignore. Essentially, what .gitignore does is it keeps your repository clean from temporary files and build artifacts. It prevents clutter from unnecessary large files, and also GitHub specifically has a limit to how much storage you can take, so it also prevents you from going over that storage limit. And it also protects sensitive info such as API keys, passwords, tokens, and more that you do not want to be on your GitHub because you don't want other people to access it. And some helpful cues to remember in case you're kind of confused on what the difference between like committing and pushing is think of commits like a snapshot of the changes you made, like you're taking a picture of it and just recording it. So it's been captured locally, but it has not been moved into your remote repository in GitHub. And you can think of pushing as transferring that snapshot. So it's as if you're sending that picture you took to a friend. So you're sending that snapshot to your remote repository. And one thing to note is that if you have not committed a change and you try to push it, it will not be saved into your GitHub remote repository. And some extra resources is we've linked some resources about cherry picking and squash merging. These are slightly more advanced concepts, but they're important to know. And you can check it out if you like. And we've created a lab that helps you get started with Git, Python, and VS Code. We very, very highly recommend that you do this before our meeting next week, so that we can get going on our personal portfolios. And this link on the bottom is just a visual way to learn Git. It's a little bit more advanced. So if you think you've grasped all the concepts from today, then you can go onto that website and learn more about Git visually.
Yeah, so big thanks to all our software education coordinators for putting this presentation together on applications and Git. We have some extra time, so Shiraz, why don't you go ahead and click on the link and we'll actually walk through the lab. This will be sent out after the meeting. The video of this meeting will also be uploaded to our YouTube so you guys can refer to it. So really quickly, this is what the lab is going to look like. And I want you guys to remember, we want this club to be very active, not in the sense of just showing up, but actually doing hands-on projects. You can't really land an internship, get work experience by being a passive listener. You have to go out there, take initiative. You have to sit down, you have to solve these problems. And our curriculum is kind of outdated and won't help you get there, especially with AI. You really have to hit the ground running, and we want to help you do that. So if you have any questions, make sure to reach out. Make sure to send us a DM. I'm pretty available online. And let's walk through this lab real quick. So the first thing we're going to ask you guys to do is install Git. Git is an actual program you have to install. It's a version control system. It's really simple. You can download it depending on the version you have. If we want to keep going. This is for Windows users. I'm personally a Mac user, but Windows operating system that's very common. So if you have Windows, you're going to have to uninstall this stuff too. Then step 3 is installing Python. So you have to install Python because it is dynamically interpreted. Uh, we're not going to really dive deep into the meaning of that. But basically, you have Python installed so you can write Python code. This will be really important for some future projects as well. So that's pretty obvious. And we're also going to ask you to use VS Code. Um, how many people here have used VS Code before? With the people with their cameras on, you guys can just raise your hand if you use VS Code before. Okay. So it looks like a good proportion of us have. Nice. So VS Code is an integrated developer environment. It's where you can actually write code. So VS Code is going to be really important in the future, right? So if you haven't set it up before, this is the perfect opportunity to get it set up. You download it, you make sure that all your extensions are installed, and then we can get started. And then our last step for this lab, it's super short, is to create a Hello World Python file, create a new repository on your local machine, create a new repository in your GitHub account, and then you have to basically change that file, make a commit, push it to your remote repository, change it again, push it again, and you should see the update. So this will give you the basics of version control. It'll teach you how to track files over time. GitHub is one of those skills that you're going to be using for the next 20, 30, 40 years, basically your entire career in software. So I highly recommend you start getting into this now. It should only take you about 20 to 30 minutes to do, and I really look forward to seeing you guys on Wednesday. With that, I think that kind of wraps up the meeting for today. If anyone has any questions, I'll be around for another 5 minutes. And I hope to see you guys on Wednesday. Okay. All right. See you guys.
Thank you all for coming. Very happy to host you guys today. The slides and the doc and the recording of this presentation will be sent out as soon as possible. So watch your emails for those.